Hello, my name's Kevin Large and I'll be your instructor for today's video. I'd like to welcome you to a series of videos which will lead through an evolving network which will be getting more complicated video by video, and we'll use the Cisco Packet Tracer tool to configure this network. Okay, this is the first video in the series, so we're going to start right at the beginning with devices and connections. We're going to look at the selection of devices, we're going to build a network topology, we're going to incorporate layer 2 switches, a couple of routers, wireless access point, end devices, these will be computers, a couple of servers and a laptop, and then we're going to connect all the devices together using the correct type of cable. And finally we're going to annotate the diagram. This will include IP addressing, but in this video I'm not going to go into great detail on IP addressing. I'll leave that for later videos. I'll talk through what I'm doing, but I'm not going to explain it in great depth. Okay. So here we have Cisco's Packet Tracer. Absolutely fantastic tool. We've got the background where we're going to build our network. We've got the different types of devices consisting of routers, considerable number of different types of router we can use, switches, both layer 2 switches and layer 3 switches, hubs, wireless devices, connections, LAN connections like your copper straight through cable and your copper crossover, wide area network connections like your serial DCE and your serial DTE, more of that later, end devices, generic PCs, laptops, servers, even IP phones, and we will be configuring IP phones on the network in a later video. Security devices, the Cisco ASA 5505, the Adaptive Security Appliance, very powerful firewall. Wide area network emulation, we've got the famous cloud, DSL modems, cable modems, custom devices, and what's known as the multi-user cloud. Now we won't be looking at that in this particular video, but who knows, maybe later on. Okay, moving back to the routers, I'm going to select some routers. I'm going to put 2 routers on the board, and they will be the 2811 series router. So I'm going to click on the 2811 and then click on the background, and do the same again to put 2 2811 routers on the board. 2811 is a nice router. You can pick the real thing up quite inexpensively on eBay now. It's quite a powerful router, very flexible, very good for practicing on. Okay, if I highlight both of them by dragging a box around them, I can move them around on the screen. Now I want to connect these routers together with a serial cable, a WAN, wide area network cable. Now currently, if I hover over one of the routers, you can see the interfaces, and all we have is Fast Ethernet 00 and Fast Ethernet 01. They're the only physical interfaces on the device at the moment. There is VLAN 1, but that's not a physical interface. What we need is wide area network connections, serial connections. In order to do that, we click on the router. This will bring up a rather useful little window. With a physical tab selected, we can see the back of the router with a big slot here, slot 1, and the slot 0 here, which consists of the 4 sub-slots, sub-slot 0, sub-slot 1, sub-slot 2 and sub-slot 3. It's not easy to say. Okay, we're going to switch the router off by clicking on the power switch and select a WIC2T card. And what is a WIC2T? It's a WAN interface card. 2-port serial card. You can see a description on the bottom here. Okay. When we select that card, the picture on the bottom right hand side changes to a WIC2T card. I'm going to drop that into the correct slot, which I'll use the bottom right hand slot, and this will cause these interfaces to be known as serial 000 and serial 001. Okay, and then we'll power the router back up. Okay, so if I hover over the router now, you'll see not only do I have 2 fast Ethernet interfaces, I also have 2 serial interfaces. I'm going to very quickly do that on the other router. Okay, so first thing, power off, select the correct type of card, which is a WIC2T card, slide the WIC2T card in the correct port, or correct slot I should say, and power the router back up again. Okay, this is good. I can now connect a serial cable because I have the correct cards in the router. So clicking on the connections, I've got 2 choices. I can use the DCE, the data communications equipment, or sometimes called data circuit terminating equipment. This is the end that has the clock rate configured on it. This is the end that's in control of the link. It's the service provider end, effectively. Easy to remember that the DCE has the clock, because you can use the little phrase, it's the clock end. DCE, the clock end, the end you put the clock rate on. Okay, so what I'm going to do, I'm going to hover over the DCE end, click on it, and the first router I select will be the DCE end of the cable. I'm going to select the high number, serial 001, and connect it to serial 000. To be honest, the two ports on the card are exactly the same. It just depends on which end of the cable you put in. It's the cable that actually is different. Okay. That's their wide area network sorted out there. This will be a connection from our corporate into the internet. Now what we need to do is we need to get some switches up. So we're going to use the 295024 switch, and I will put 3 of those on the board. Okay, and while we're here, we'll just put a wireless access point up, a little generic wireless access point, and we'll put some end devices on the board. So we'll go for a generic PC underneath that switch there, and another one under that switch, and another one under that switch, and we'll put a server over here somewhere for a little server farm. Okay, just tidy things up a little bit. That's looking good. Right, there's a server. Oh, I need to sort the internet out, so we'll put a switch up in the internet here, because this will be another site, perhaps one of our branch offices off on the internet there, and a router. No, we don't want a router, we want a server. Another generic server. So that's a server out on the internet. That can be a web server. Okay, so looking good, looking relatively tidy. I'll tell you what we want to do. Let's make it look even tidier. Let's click on the little drawing palette up the top here. Brings down the drawing palette dialog box, and we'll click on fill color, select, I'll have a blue color I think for the internet, and select the rectangle, and then what we'll do is we'll just put a little rectangle around the internet. That's our internet connection. Everything there is the internet. And we'll do, let's see, a yellow for our corporate internet, or corporate intranet to be more precise. So our corporate intranet will be over here with the servers in there. That's looking good. We can close the color palette, and we'll carry on wiring up the devices. Now, be aware, if you use a straight through cable, that's normally used to connect different types of devices on each end of the cable. So for instance, switch, fast Ethernet 01, I'll use the lowest number, to PC. Obviously a switch and a PC are different, so we use a straight through cable. Switch, fast Ethernet 01, to PC, fast Ethernet 00. Okay, that looks pretty reasonable. One more there. Switch, fast Ethernet 01, to PC, fast Ethernet 00. And then we'll move across to the switch. I'm going to actually use fast Ethernet 010. The reason for that will be apparent later. So fast Ethernet 010 on the switch to the server fast Ethernet 00. A switch and a server are not the same thing, so that works okay. Switch fast Ethernet 02 to the wireless access point. Fast Ethernet, actually it's just port 0 is the wired port on the wireless access point. So we've used straight throughs so far, dissimilar devices at each end. In fact, there's a router. We'll take fast Ethernet 00 and connect that to the switch, and we'll use the highest port actually, fast Ethernet 024. Okay. Now for similar devices on each end of the cable, we use a crossover cable. So clicking on the switch, I'll take fast Ethernet 023 and connect it to the next switch along, fast Ethernet 024. So that's 23 to 24. I'll do the same thing on that switch. In the middle, fast Ethernet 023 to fast Ethernet 024. Okay, you'll notice crossover cable, same device on each end, straight through cable, different device on each end. Now there is one exception. If you connect a PC directly into a router, you actually have to use a crossover cable, even though they're different devices on each end. That's because normally a PC would never connect directly into a router. It would go through a switch, and the switch is doing the crossing. So if you take the switch out, then the cable has to do the crossing, and you'd use a crossover cable to connect PC to router. Okay, so that's those done. That's looking good. What do we need to do now? Let's do a little bit of labeling. Oh, missed some connections. Right, router, fast Ethernet 00, switch, fast Ethernet 024. The ports on the switches are all the same. All the fast Ethernet ports are the same. You see, they're all the same speed. They're all fast Ethernet. We'll take fast Ethernet 01 and plug it into the server, fast Ethernet 00. Okay, that looks pretty neat. So we're all wired up now. I just want to label some of this. So I'm going to label this as the internet. I'll do it in capitals so it's easier to see. Okay, so there's our internet, and over here we'll call this the corporate. Hopefully spelling it correctly. Looks good. Intranet. So this is our internal intranet. Okay. We'll need some IP addresses. Well, this link here is on the internet, so this will need what's known as a public IP address. I'm going to make that 88.40.12.0. I'm just making that number up off the top of my head actually, but it is a what's known as a Class A public address. I'm going to put a subnet mask on there of /30. That's a 30-bit subnet mask. 31's in the subnet mask, 2 zeros left over for hosts. 2 to the power of 2 gives you 4. There's 4 networks. That's the network, the broadcast, on one end of the cable and the other end of the cable. So there's our network address. We will put .1 on one side. We will put .2 on the other side. So .0 is a network address, .1 is one side of the cable, .2 is the other side of the cable, .3 would be your broadcast. And for our organization, we'll use a Class B private address, 172.16. Let's say 10.0. And we're going to have a reasonable number of hosts, so I'm going to have a /23 on there. Okay, that's looking good. This particular network off here, that'll have the most hosts on. That'll have 200 hosts. And that will be including the wireless hosts, which we will configure in a later video. Okay, looks good. Now we're going to actually put that in what's known as a VLAN. VLANs will come up in the very next video. That will be put in VLAN 10, and we'll name the VLAN sales. And we're not going to configure that in this video, we're just going to label it for the next video. Okay, so I didn't put the word hosts in there, did I? No, I didn't. Right, 200 hosts. That's better. Right, now carrying on. Next biggest network would be, well, we'll say this one here. So this will be 50 hosts. And this network we will put in VLAN 20. And we'll call that research. Okay. The rule is that each subnet is a VLAN and each VLAN is a subnet, but we'll get onto that later. 25 hosts, and we'll put that into VLAN 30 and call that one, well, we better have a management, otherwise they'll only get upset. Management, except for I can't spell VLAN. That looks better. Okay, and finally, better not forget the servers. That can be VLAN 40, and we'll call that servers. VLANs are wonderful things. They allow you to sort of separate the ports on a switch into different logical broadcast domains. It's really clever stuff for the next video. Okay. Now, so we have 25 hosts on the management VLAN. We have 50 hosts on the research VLAN, and we have 200 hosts. That's the biggest one in the sales VLAN. Lots of salespeople. 200 hosts including wireless, and of course we need to have some hosts in the servers VLAN. So how many should we have? Just have a few servers. 10 hosts. Looking good. Right, now we need to do a little bit of subnetting. So 172.16.10/23 mask. Well, there's 32 bits in an IP address, so if 23 of those are ones, that means we've got 32 minus 23, which is 11. No, it's not. It's 9. Maths lost me completely there. So 32 minus 23 is 9. 2 to the power of 9 is 512. There's 512 addresses, 2 of which we can't use, the network and the broadcast. So we've got 510 usable addresses. Well, that's more than enough by the looks of things. So how do we do our subnetting? Well, let's see. 172.16.10/23. Always start with the biggest network. So that will be the sales VLAN with its 200 hosts. That will take the main address, 172.16.10.0. But obviously we need to work out what the subnet mask is now. So we need 200 hosts, plus the network and broadcast, and the default gateway, because we will need an IP address up on the router there. So that's 200 hosts, network, broadcast, default gateway, that's 203 hosts. What's the nearest binary number to 203 that's bigger than it? 256. 2 to the power of what is 256? That's 2 to the power of 8. So we need 8 zeros in a subnet mask. Right. Subnet mask is 32 bits. So if 8 of them are zeros, then 24 of them must be ones. So that means we've got a /24 subnet mask. Excellent. Next, subnet. Well, this one will start where the previous one ended. So that had 256 addresses on it. It was a subnet whose block size was 256 addresses. 256 addresses will not fit into an octet because they'll only go from 0 to 255, which is 256 addresses. So the next one will start at 172.16.11.0. It's a bit like the speedo on your car when you get up to 999 miles and you add an extra one. All the 9s turn to zeros and you get a 1 in the next column along. Same thing here. We went from 10.0 all the way up to 10.255, which is the broadcast address for this VLAN 10 network. Added one more bit, and that made the 255 go back to a 0 and made the 10 to an 11. Okay, don't worry if you didn't understand that completely, because we will be doing subnetting in a later video. Right, I want 50 hosts on the research. 50 hosts. Okay. 50 hosts plus the network, broadcast and default gateway, that's 53. Nearest binary number to 53 that's bigger than it, 64. 2 to the power of what is 64? 2 to the power of 6 is 64. So that's 32 minus 6, 26. Okay. So that one started at 11.0 and it's 64 big. So that means this one will start at 172.16.11.64. Okay, so this research VLAN started at 11.0 and it was 64 big, 64 addresses. So that went from 0 to 63. So the next one starts at 64. Okay, 172.16.11.64. 25 hosts. Network, broadcast and default gateway, that's 28 hosts. Nearest binary number to 28 that's bigger than it, 32. 2 to the power of what is 32? 2 to the power of 5 is 32. So that's 32 minus 5, 27. Okay, /27. Right, so this one started at 64. It's 32 big. So if it started at 64 and it's 32 big, 64 and 32 are 96. That means the next network up will be 172.16.11.96. We need 10 hosts plus the network, broadcast and default gateway. That's 13 hosts. 2 to the power of what is 13? Oh, sorry, we need a number bigger than 13, don't we? That would be 16. So 2 to the power of what is 16? 2 to the power of 4 is 16. 32 minus 4 is 28. Lovely. Okay, so there's our IP addressing. We have all the networks on. Great job. Oh, we need to do the internet. what should we have for our internet addresses? Let's have another private address range. We'll use a Class A private address range. We'll use the 10 dot anything, in fact, is a private address range for Class A. So we'll use 10.10.10.0. How about that? And we'll use a /24 on there. Okay, /24. 32 minus 24 is 8. 2 to the power of 8 is 256. So that has 256 addresses. One's the network and one's the broadcast. So we have to subtract those. So that's 254 possible addresses. Okay. Let's make this end .254 the highest usable address. Why can't we use 255? Because 255 is the broadcast. And we'll make this end .1 the lowest usable address. Okay, that's looking good. Excellent. Well, actually, I think I will stop there because we've built the network, we've wired it up, we've done a little bit of IP addressing, we've labelled the network. We'll call it a day for that video, and we'll continue in the next video by putting VLANs onto the switches and trunk links between the switches. Okay. I hope that video was useful to you, and tune in for the next one. Lab 2, VLANs and trunk links. Thank you very much.